My name is Jack Dangermond, and I want to start off by saying thank you and acknowledge both USGS and the National Weather Service, which of course is part of NOAA, for inviting me to testify at this briefing. I am honored, deeply honored, to be able to share my views with you and give some insight to the work that I've been observing now for several years that's underway at the National Water Center. My background is that I started about 50 years ago a company which has become the world's primary supplier of geographic information systems. These are software systems that manage geographic phenomena. It's used for analytics and visualization, for map making, mostly for bringing things together using maps as a common framework. I have about 350,000 users or organizations who use my software. It's not exactly like Microsoft, but it's something like that within our earth science and land use domain. So I give this background because what I want to share about what the USGS and the Weather Service have been doing collaboratively over these last few years has profound meaning for my customers. Not so much me, but my users. These users are in public safety, in state and local organizations. They're often the first responders. They're the planners. They're the organizations that manage assets, property, people. They do this all with geographic information systems. What this center has done is developed a new kind of model. It's akin to a new satellite for the weather, but it's not a satellite. It's a model. It's an analytic framework that brings data together from USGS, the streams and stream flows, together with satellite data from the Weather Service, and models and forecasts the future flows of streams a couple days out or a couple even weeks out before a storm event happens. What this means is the forecasts of the weather are made, and we know these from TV, and they're layered on top of topographic maps and stream flow maps. The water runs through these networks and gives a projection, just like the weather projections, for what's going to flow in every stream in America. This is profound because it's bringing big data from all these sources together, using a GIS to manipulate the data and then make the forecast so that we can see and, as a response, understand and, as a response, act in a different way. Imagine this electronic map being available to all the cities and counties, my users across America, as well as private companies like railroads and utilities and businesses who are often affected by the effects and aftermath of major flooding events. And so I just want to say, in my career, working with different forms of science and technology, this is one of the most worthwhile and interesting projects that I've ever seen come out of the federal government as it relates to my customers, my users. I hear from them their excitement, and I truly am excited myself because it's like seeing into the future what's going to happen and therefore being able to respond more effectively. This I think of as national information infrastructure organized by the country's best scientific organizations, but delivering science into people that don't know science so much, but know how to apply these information maps to real activities in their local government. So I want to acknowledge the insight that led to this new center being established, and particularly this piece of work coming out, the National Weather Model and the National Water Model, which I think will open a new chapter, a sort of transformational chapter in the history of how we are able to respond to disasters. I want to also thank the academics that have been involved in formulating these models. You'll be hearing from some of them as well today. So thank you very much for this opportunity, and thank you for your support of this program. Thank you.